In this session, we're going to solve absolute value equations, which turn out to be almost linear. In order to understand what we're going to do with absolute value equations, it's useful to remember what an absolute value is. The absolute value of a number is its distance from 0. And so the absolute value of 4, being 4 units away from 0, is equal to 4. We could also say that the absolute value of negative 4, being 4 units away from 0, is also 4. So a way to combine these two thoughts is to say that the absolute value of either positive or negative 4 is equal to 4. So when we solve an equation that has a variable inside an absolute value symbol, say the absolute value of x is equal to 4, we can think of this as whatever the number is inside the absolute value symbols, the positive or the negative of that number is equal to 4 in this case. That leads to the idea that either positive or negative x is equal to 4, and because we want to get the x by itself, we're going to take that plus or minus, move it to the right hand side via multiplication or division, and we're going to end up with x is equal to plus or minus 4, which we know means x is equal to 4, or x is equal to negative 4. These are the facts that we're going to use to solve absolute value equations. The first equation that we have is absolute value of 2x is equal to 16. And we're going to write down two equations. For one of them, we don't change anything except we drop the absolute value bars, and so we write down 2x is equal to 16. But for the other one, we're going to use the negative 16, and so we have 2x is equal to negative 16. In each of these cases, we're going to solve the equation by dividing by 2, and so we get x is equal to 8 for the first equation, and for the second equation, we're going to get x is equal to negative 8, and we can write that as x equals 8, comma negative 8. Here's an absolute value equation that I'd like for you to try on your own. And here's the worked out solution so that you can check your work. In our next equation, we have the absolute value of 5y minus 4 plus 3 is equal to 11. Now before we can split this up into two equations, we need to isolate the absolute value expression, in this case by subtracting 3 from both sides. So we'll go ahead and do that, and we end up with the absolute value of 5y minus 4 is equal to 8. Now we can split this into the two equations as we've been doing and get 5y minus 4 is equal to 8, and for the other equation 5y minus 4 is equal to negative 8. We'll solve each of these equations as usual, which means in the first equation we're going to add 4 to both sides to get 5y is equal to 12, and then we'll divide both sides by 5 to get y equals 12 fifths. For the second equation, we'll also add 4 to both sides. We get 5y is equal to negative 4, and dividing both sides by 5 gives us that y is equal to negative 4 fifths. We'll write the answers separated by a comma, and those are our solutions. Here we have an equation that's similar to the previous one, and our first step is going to be to isolate the absolute value expression, which in this case means subtracting 8 from both sides. And here I see I have the absolute value of 3t plus 2 is equal to negative 7. Now an absolute value expression is never negative. So on the left-hand side we have an expression that's never negative, but on the right-hand side we have a negative number. Since this can never be true, in other words, we have a false statement, we're going to say that this has no solution. And another way to write that would be to use the empty set symbol. Either one of these answers is acceptable. In this equation, we have the absolute value of 5m minus 2 is equal to 4m plus 7. And we're going to handle this the same way we did before, even though there are two terms on the right-hand side. We're going to write down two equations. for one of which we drop the absolute value symbols and write everything else as is. 5m minus 2 is equal to 4m plus 7. And for the other one, we're going to drop the absolute value symbols. We're going to write down the negative of what's on the right-hand side, but since it has more than one term, we're going to wrap that in parentheses. We'll solve each of these as usual. Subtract 4m from both sides to give me m minus 2 is equal to 7, and then we'll add 2 to both sides to get m is equal to 9. For the other equation, we need to distribute the negative, and so we have 5m minus 2 is equal to negative 4m minus 7. I'll add 4m to both sides. We get 9m minus 2 is equal to negative 7. Then we'll add 2 to both sides to get 9m is equal to negative 5. And then dividing both sides by 9 gives us negative 5/9 as a solution. And here we are. If you'd like to see how to check this solution, I've included it at the end of this video. In this equation, we have two absolute value expressions, and this could seem a little daunting, so before we solve this, let's consider something a little more basic. Suppose we have the absolute value of x is equal to the absolute value of y. In keeping with what we saw in the first slide, we can say that we have plus or minus x in absolute values is equal to plus or minus y in absolute values. And so we have plus or minus x is equal to plus or minus y. Now this gives rise to four equations. For one of them, we're going to equate the positives. We end up with x is equal to y. For another one, let's equate the negatives. And we get negative x is equal to negative y. Now let's do some mixing and matching. We'll match up the positive x with the negative y and end up with x is equal to negative y. And then finally, we'll match up the negative x with the positive y and end up with negative x is equal to y. The good news is that these four equations actually reduce to two equations, because x equals y and negative x equals negative y are equivalent equations. Likewise, x equals negative y and negative x equals y are equivalent equations. And so in other words, we're going to do exactly what we've been doing, and that is we're going to write down one equation that drops the absolute value symbols. And for the other equation, we'll drop the absolute value symbols and use the negative of what's on the right-hand side. And so we see we have 8 minus 3x equals 2x minus 7. And for the other equation, notice that we have the minus sign in front of the parentheses, because this is a binomial. Solving as usual in this case means we're going to add 3x to both sides, and I have 8 is equal to 5x minus 7. And then we're going to add 7 to both sides to get 15 is equal to 5x. And then finally, after dividing, we get x is equal to 3. For the equation on the right-hand side, we're going to distribute the negative, and we'll have 8 minus 3x is equal to negative 2x plus 7. I'm going to add 3x to both sides. That'll give us 8 is equal to x plus 7. And then finally, subtracting 7 from both sides gives us x is equal to 1. I'll again write the answers separated by a comma. Here we're going to check the solutions x equals 9 and x equals negative 5/9 with the equation absolute value of 5m minus 2 is equal to 4m plus 7. To check our solution, what we're going to do is we're going to substitute each value in term where we see the variable in the original equation. And so here I have the absolute value of 5 times 9 minus 2. And since we're checking it, we're going to put a question mark over the equals sign. And on the right-hand side, we have 4 times 9 plus 7. Inside the absolute value symbol, we can multiply following the order of operations to get 45 minus 2, which leaves us the absolute value of 43, which is of course 43. For the right-hand side, we're again putting a question mark over the equal sign, and 4 times 9 is 36. When we add 7 to 36, we get 43. Since 43 is equal to 43, that solution checks out. Now we'll check the solution x equals negative 5/9 by doing the same thing we just did. On the left-hand side, we have in the absolute values 5 times negative 5/9 minus 2. On the right-hand side, we have 4 times negative 5/9 plus 7. We're going to work one side at a time, and inside the absolute values, we get negative 25/9 minus 2. Now remember, we need common denominators, and that 2, expressed as a fraction with a denominator of 9, is going to be 18/9. So we write negative 25/9 minus 18/9, which is the absolute value of negative 43/9, which is of course 43 over 9. On the right-hand side, we have negative 20/9 plus 7, and once again we need 7 to have a denominator of 9. In order to do that, we're going to multiply by 9 over 9 to get 63 over 9. And so we have negative 20/9 plus 63 over 9, which equals 43 over 9. And since 43 over 9 is what we had on the left-hand side, this answer also checks out.